Hello everyone, welcome to another episode of Solving Advent of Code in Rust and try to learn Rust in the between. I am Roberto and we have
Eugene?
And Luciano.
Thank you everyone for following along. If you never did an Advent of Code is a challenge that is published every year around Christmas. We work toward the last year one, and there are 24 challenges you can find on adventofcode.com. We publish our code in a Git repository, Banner.
Banner is coming. Sorry, I wasn't ready. Now I am.
We are publishing all the code here, and we also have a YouTube channel that you can find somewhere in the Twitch description. And for the one seeing the video on YouTube, you can follow us on Twitch. You can find all the links in the channel description. Last time we were doing part 2 of exercise 16, and we have some improvement because we wrote a solution that was working, but it was a little bit clumsy. I mean, we avoided borrowing mutability and stuff like that with dirty tricks. So we are trying to work on it again. So who is going to share the code today?
Do we want to start by showing the PR we got from Tommaso?
Okay, so let's start with a pull request we got from somebody that is following us. And you can still share the screen, or do you want me to do that?
I think I am, yes.
Okay, you are starting to share something.
So this pull request, zoom in.
Yes.
This pull request was about replacing our nested for loops, as you can see, for all the ticket, for all the numbers in the ticket, find the broken numbers and sum them together.
Yeah, another thing that we do is we have this explicit accumulator.
Yeah.
And then in the nested for loop, we keep increasing this value. So here, Tommaso is suggesting us a little bit more elegant solution that uses the Rust combinators. So rather than doing an explicit for and then a nested for, we do this thing.
Here I want to point out the flat map, because we have a list of strings, vector of strings, that we are going to split on comma. So you will come with a vector of iterables, and at this point is a bidimensional structure. But we don't care about the position of those numbers. We just care about the numbers. So with flat map, basically we are getting just a vector of strings that are the single numbers of all the tickets. Then there is that parse with cast from strings to str to u64. Interesting, the filter map to get only the result that are okay. Line 61 is interesting too.
Because this one, of course, might fail. We know it's not the case, but it might still fail, right?
Yeah, from that one, when you parse, if you don't unwrap, you don't have value. You have a, how is called, result, right? Yeah, yes. So to unwrap the result. Yeah.
So in theory, we could have done also this, dot map result unwrap. But this one, if it fails, is going to panic. This one, if it fails, is just going to filter out the value. So the value is not going to be included in our final computation, let's say.
For us, nothing is changing, but it's a little bit more elegant, I think, with the filter map. Then the work of checking if the number is valid or not is done in line 64. So we filter the one that are not, there is a not there, in any rule. Interesting also the any. And then the 66, sum all together. This line doesn't end with a semicolon, so this is the returned value.
Exactly, yeah.
This is always bothering a little bit me in Rust, that you don't have an explicit return.
You can have it. I don't think it's going
Yeah,
to...
you can have it. It's not forbidden, but it's not idiomatic of the language, I think.
Yeah, it is frowned upon to put it there, I think. Maybe not frowned upon, but...
So,
yeah, fair enough.
There are two tests that run on top of this pull request
Let me switch.
for performances regression, but there are no regressions. So it's the 16. So you have to scroll down to 16. Yeah. Okay. 0.65% can be a fluctuation due to whatever.
Yeah, it's not a significant difference,
No,
but
it's
for
not
sure it's not slower, basically.
It's not slower. It's not slower. As you see, the other one are stable around 0.03. This is probably even a little bit faster, but very little bit. There is also Cargo Bench, but Cargo Bench is a little bit less constant in times. I mean, he's looking at real times, and yeah, and still, even this one tell us that this is a little bit faster, obviously. More than before, but Cargo Benchmark is not very stable because of the CI infrastructure that is in GitHub. So you can land on a fast machine, and you can land on a machine that then is virtual, so you get CPU deprivated by another task that is running. So Valgrind is way better metric.
Yeah, because if I understood correctly, Valgrind is basically checking the total number of instructions, basically, right?
Yeah, it's checking the number of time that you read from L1 cache in a virtual CPU that is allocating for you. So basically, this number of access to the L1 means the number of assembly instruction fetched by the program itself. If you look at the number is a huge number in the action, because like billions of these small assembly instructions. And for this reason is way more stable as number, because it doesn't take in account the time that you need to perform the action.
Yeah, by the way, if you're curious, you can see all our actions on the same repository we showed before, because it's just YAML files. So you can see exactly how we are running these benchmarks for every PR. We're probably going to try to do a dedicated episode if there is enough interest. So let us know if you think it will be worth it for you.
Cool. So
cool. So shall we merge it?
Squash and merge and pull.
Squash and merge. Perfect. So now I'm going to pull and share my editor. So just
we should also say thank you, Tommaso.
Thanks a million, Tommaso. I don't know if you're live today, but hopefully you're going to hear our thank you at some point. All right. So now let me share my editor.
Before having a beer, you need to submit 5 pull requests.
I think Tommaso might be close. Okay, perfect. So here is the code from, let's see if we have the changes from Tommaso. Yes, here they are.
Zoom in.
Okay. And we also have the second part. So the issue with the second part, and if you see the recording from the previous episode, you might have a lot of fun with ourselves swearing for most of the episode, was that we decided to do something that I think it makes sense. It's just that maybe we are not experienced enough to do well. But the idea was essentially the problem is like a combinator problem, I guess, where we have values and then, well, we have rules and then values. And basically this, the combination of the two allows us to figure out exactly which columns is what. So it's like we don't know the order and the value of the columns. We just need to double check all the rules. And by exclusion, we're going to figure out which column is what. So to kind of abstract the problem, you can imagine you have like bidimensional matrix, right? And basically you're trying to check which rules connect to each other, and by exclusion you're going to find that only one rule is going to match exactly that column, and therefore if you keep doing that, eventually you're going to find the exact order of columns. Does that make sense, or you guys want to explain it a little bit better?
I think it makes sense.
No, it makes sense.
So so basically the way we modeled this problem was by creating a vector of hash set of references to rules. And rules is something that we defined originally as, here we have our own type. Essentially a rule has a name and 2 ranges. And you can see if a value is satisfying a rule by checking if it's either in one range or the other. So essentially, we already have had all this logic, and we already created a structure to simplify our lives. So we thought, okay, let's define our starting structure as a vector of, here it is, vector of hash set of references to rules. So basically what we did is working with references of rules, because of course it makes sense. We have these objects already. We need to use them in different contexts. We don't want to duplicate them all the time. We are going to reference them as soon as we need them. The issue with that is, of course, that if you know a little bit of Rust, when you deal with references, there are all the usual rules that apply to make sure your code is safe. For instance, you can have multiple references to the same object only if they are not mutable. As soon as you have a mutable reference, that needs to be the only one in context. So, of course, all these rules are good because the code is safe, but they make our life a little bit harder because you lose a little bit of freedom in the way you structure your code. So we needed to work around a little bit backwards to try and kind of fulfill these rules. And I think the code is not clean because of that. Like, we took a little bit of shortcuts, I guess I'm going to say. And just to show an example, here we couldn't figure out exactly how to escape one of the Rust rules. So rather than doing a regular loop where we iterate over directly on the list of rules, we are doing a for loop using indices, and then we use that index to get the rule whenever we want to use it, which I think is fine.
To get the hash set of the rules and modify it, because the problem is that we have to take the rules and change the hash set in that for, and
we need to remove them.
And we use get mute of that index to get the column instead of be able to do 4 column in guesses, something way more simpler. But if we do that, we start to have double reference inherit, lifespan and borrowing
so one idea I think the problem there was that if we were iterating directly over the hash sets, then you are kind of mutating the hash set as you iterate. So that was creating multiple references.
We are iterating on guesses that is a vector of hash sets, and then we are changing the hash set. That is, in theory, is an object in memory. So the vector contains the object there. If we declare it mutable, we must be able to change it, in my opinion. But this, we can start from here, for example. Let's try to make this not for number in, but for columns in guesses. And we see what was
the problem.
Yeah, what was the problem last time?
Yeah, for what did we call it? Columns.
With S, because it's a hash set of multiple columns.
Yes. In guesses.
Yeah.
And then basically here we can comment this one out.
Line.
I am writing Python.
Oops.
And this one is saying that it gets moved. So we can do iter, I think. And then here is saying that you cannot borrow columns as mutable because it's behind a reference.
We have a suggestion for iter mute.
We can try iter mute. Thank you, amPerl, for that. Mute. And that does remove the problem. So I don't know why we didn't figure out this one last time. So we probably needed more help.
Probably we were tired the last time because it was
Yeah.
after 1 hour and a half of streaming and we were burned.
So this one maybe is not too bad.
Run the test to see if it works.
Still working perfectly.
Yeah.
Working. The external loop that we have a loop with a break. When I see a break, I always think if I can make my logic better.
Mm-hmm.
This can be while sure column is less than guess len.
Now that break is there because this loop doesn't have an exit condition.
Yeah, this is our infinite loop. The one in one line,
Mm-hmm.
133.
We can do a while.
Yeah.
These things are not equal, I suppose.
Yes, until they are not equal, but sure column is less than guess len.
Yeah, exactly.
The logic is that while it is less, let's loop and remove the if with the break this time.
And then let's run.
You're fighting with the editor.
Right.
Run the test and let's see if it crashes your machine.
It didn't, so that makes sense. All right. So what else can we improve? I think there was a warning somewhere here. Or was it removed?
Somebody's asking if you use Clippy. Is Clippy the one that suggests you better code?
Yes, I think I have it enabled and there was a warning, but maybe we just removed it.
No, I think I see it before. Scroll up.
Because it will show up here and it's not.
Mm-hmm.
Maybe we fixed
it.
It
was when we do the remove. When we do the return. We have an early return in a closure app. If you scroll up. There online.
This one, right?
Yeah, it was complaining there. Why is not complaining anymore?
Let me restart.
Mm-hmm.
Nope.
Now he's happy about it?
No, don't push and pull. Yeah, it's happy. If we do cargo check. Cargo check, I think that should run Clippy.
Okay.
Right? Or is it cargo Clippy? Oh yeah, that's it. So for some reason Clippy is not running anymore.
Okay, because...
So it's still not liking this, and it's saying you can replace it with found question mark.
Yeah, but you were saying something about it. What were you saying about
I think this will make sense if you want to return always. Here we don't want to return always. Here we want to return only if it's none and continue otherwise. So this is the reason why I wasn't sure about this suggestion.
What exactly does found question mark do?
Okay, so you see here we have a good comment. Found will return none if found is none, which we don't want to do. So if found is none, we want to continue, right?
No, if found is known, we return known. If found is not known, we want to return some ticket.
Yeah.
Okay.
We don't want to return found.
Essentially, this is a... Oh no, it's not even a ternary because the other return is outside of this loop.
Yeah, the other return is outside.
Exactly. So
basically, this one is filtering the broken tickets, right? Is that piece of code?
Mm-hmm.
Yeah.
Maybe we can use a filter.
We've got some more comments from amPerl saying that they do prefer how we have it right now because it's clearer what we're doing.
Yeah, I suppose the alternative would be to use a filter.
Yeah,
but instead of find.
Let me remember what was the logic there.
Here the logic is that the other tickets are not all valid. And we have to filter out the invalid ones.
And for every ticket, you have a collection of numbers. So we need to check every single number. And if we find one number that is not valid, we discard the entire
ticket. Not that number. We discard the entire ticket. So, yes, the logic here is different, and Clippy is not grasping it because it's a little bit too complex probably for Clippy.
Okay. Yeah, I don't know if there is a way to disable this suggestion.
Probably there is a way to do this code in a little better way. So let's think about it. Basically, okay, at this point, what we could do is having a ticket structure that is just a vector of numbers with a method is valid. And to the method is valid, you pass the vector of rules. And this is returning you what? Known or something or some self. I don't know.
So it's gonna do all this thing.
Yeah, in a validation method inside the ticket. At that point, that validation method can return some self or known, and we are just returning it straight away.
Do we want to make a struct for the ticket? Because we don't have one yet.
The ticket for us now is a vector of 64.
Yeah.
Nothing else. That is what it is. I mean.
Yeah.
But to add a method on top of something, you have to declare a type. I think so.
Yeah, we will need to wrap it in a type, I think. I'm not aware of it.
We can create just a function that do the same and is returning sum of ticket or known based on this rule. So we create a valid ticket, you pass the ticket and the rules, and then this function returns some ticket or known based on this logic. So
there is also a suggestion if we want to disable Clippy, we could just do something like this, I think.
For me, like this is readable probably because we wrote it. So it's readable because we wrote it.
So basically, this is the suggestion here, and I think we need to add it where? Above the statement, like here, I guess.
The line before, yeah.
And here we need to say allow.
Allow.
And now let's see if it's still complaining. No, it's not. So good. We learned how to silence Clippy if we want to. Thank you, amPerl, for all the information. Okay, so let's... do we stop it at there? I don't think it's worth doing a function there.
No. Let's keep like this. Like I
We
say.
also got a new follower, so thank you.
Nick Lovin. All right, so let's see if we can do something else. Because I had this idea where we will dramatically change the structure of everything just to fix this issue. But at this point, I don't think it's fixed anymore, right?
Yeah.
So maybe what we can do is to start the next exercise. I can commit all this stuff.
Yeah, just do a commit to mark the point.
Perfect. Nice. I'm actually happy that we figured out an easy way to make it nicer. Thank you, everyone, for the suggestion.
Why last time we didn't figure it out? Because in the end, I think we said I don't know. Sorry, guys.
I have a feeling we tried it, but maybe there was some other issue in between when we tried that. And then we kind of disregarded that solution entirely because we didn't realize maybe there was some other issue as well.
I think we wanted to focus on getting it done because that's generally how we go about it. Get it working and then make it nice, which is basically what we were doing right now, just making it nicer.
So, Eugen, do you want to drive on the next one, or do you want me to
Certainly.
continue? Okay, then I'm gonna stop and give you control.
Remember to comment.
I did, so make sure you pull.
Remember to pull.
Exactly, I'm going on the main branch now and pulling. Apologies, I'll share my screen in a second. Cool, I got the changes. And let me get to VS Code. Now, where's the share screen button? Share screen. First Advent. So let me know when you can see it.
I have to add it.
Yeah, you need to add it to the thing. All right, now we'll be reading this together because I don't actually remember this.
Can you make it a little bit bigger, please?
I can, and I will. Let me just zoom in. Is this okay?
I think it is okay now.
Yeah, it's fine.
There was a way to close this bar thing, but I don't.
Control B.
Control B. Yeah, nice. Sorry, I don't know VS Code very well.
I only know the shortcut. I don't know how to do that with the mouse.
Perfect. I prefer keyboard. All right, so I'll briefly read through the thing because I think we all need to understand it. I did clean up the README, but I don't remember anything from it. So, as your flight slowly drifts through the sky, the elves at Mythical Information Bureau at the North Pole contact you. Interesting. They'd like some help debugging malfunctional experimental energy source aboard one of their super secret imaging satellites. Jeez. Okay, the experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. And here it's having problems. You can't help but agree to take a look. Okay, so the pocket dimension contains an infinite three-dimensional grid. At every integer, three-dimensional coordinate, so x, y, and z, okay, or z. There exists a single cube which is either active or inactive, okay? So in the initial state of the pocket dimension, all the cubes start as inactive. The only exception to this is a small flat region of cubes, which is the puzzle input that we'll get, okay? The cubes in this region start in the specified active, which is marked by a hash, or inactive, which is marked by a dot state. The energy source then proceeds to boot up by executing 6 cycles. Cool. So each cube only ever considers its neighbors. Any of the 26, this should be highlighted, other cubes, where any of their coordinates differ by at most 1. So for example, given a cube at x1, y2, and z3, its neighbors include the cube at x2, y2, z2, and the cube at x0, y2, z3. Okay, and so on. Okay, fair enough. So it's all the neighboring cubes in
any of the
3D
26
space.
other cubes.
Yep. Yeah, exactly. Okay, so during the cycle...
Sorry, but how many cubes do you have as neighbor?
It's not 26. So since it's a 3D thing, it means you have... No, you have 9...
The entire space will be what? 3 by 3 by 3, right?
No, it's infinite.
Yeah, it's direct neighbors, right?
Sorry, like if you have one dot in this 3D space, the space around it will be 3 by 3 by 3, right?
I presume, yeah, but I don't know if it's talking about this kind of neighbors or if it's considering these ones as well.
Yeah, but even with diagonals,
like diagonals.
How many do you have if you are a point in the space? You have 9 below you,
9 below, 9 above,
and 8 at your position.
Exactly.
9, and 8 is 26. Okay, I'm an idiot. Yeah. Perfect. Sorry, my fault.
It's interesting that it doesn't. Let's see if from the input we can figure it out. So x1, 2, and 0. Y is 2 for all of them, and Z is 3 and 2.
Yeah, he's the one above and below.
I think it's just the direct neighbors, not diagonal. So like
no, also diagonal. If it's 26, it's also diagonals.
Ah, yeah, you're right. 26 other cubes. Jesus. Yeah.
If it's not diagonal, it's a 9, is a 6 because it's 4
Exactly,
plus
yeah.
the extra dimension. So 6.
Sorry, guys. My
If you
buffer
take
size is
the
small.
diagonals is 9 above, 9 below, and 8 on your level. So 9, 9, and 8 is
Mhm.
26.
Correct.
Sorry, I was just thinking that a cube 3 by 3 by 3 is 27 cells.
It is,
Yeah,
but you have to
we
exclude
got
yourself.
we got this comment as well.
Ah, thank you.
Yeah, you are the middle one of the 27. Yeah,
Exactly. Yeah.
Three-dimensional
Alright.
thinking is not my main.
Fair.
My main
All right,
power.
let's see. So during the
Okay, let's go.
cycle, all the cubes simultaneously change their state according to the following rules.
Game of
If a
life.
cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. If a cube is inactive but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains the same. Okay, so they change. Sorry, they stay active if they have 2 or 3 neighbors that are active, and they change to active if they have 3 neighbors active.
Yeah, it's game of life with 3 dimension, and I don't remember if the number are the same or not. I don't think so.
All right, I've never done Game of Life, so this should be fun. So the engineers responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of cubes should be at the end of the 6-cycle boot process. Okay, so we get this initial state.
Yeah, let's see how we read it. Because this seems bidimensional, right?
It does indeed.
Yeah, because they are just providing us the central layer. They say they start just in a central plane, and then obviously you expand above and below.
Okay.
Okay, so this... But this is only 9 neighbors. This is 2D.
Yeah, the first level is just one level. So think of that as the first level 3 by 3 by 1, because it's only
It
height
says
1.
it. I didn't read the next sentence.
Okay.
The next sentence says, even though a pocket dimension is 3-dimensional, the initial state represents a small 2-dimensional slice of it. Okay, so this is 3 by 3 by 1. There's no depth to it. Okay, cool. So we are inactive because we're a dot.
If you scroll, I think there is the next iteration.
Before any cycles.
Okay, this is the start. That is just at Z0. Okay. Then it will become something in Z1, Z-1, Z1, and Z0, because
yeah, the
grow
next slices, yeah.
and then
let's see how they change. So we, the dot, have stayed inactive. No, we turned active. So this is Z0, Z0. The square above us has turned inactive from active. The square to the right stayed active. The square to the left stayed inactive. Sorry that I keep scrolling, I've got a bad mouse. The square below, the point below has stayed active. And then some others were generated. So basically, is the idea that we start from a slice and then we generate outwards?
Yes, we generate. We have to compute all our.
Yeah, I think every cycle we add 2 new layers in depth, right?
Yeah, one above and one below. Probably because there can be that there are no rules, or can be that we shrink one level because the rules kill everybody. We don't know. Depends on.
We don't shrink it. I can see it just keeps expanding. So
this input keeps expanding. This input keeps expanding. If you start with an input with just an hash in the middle, just one, the next iteration is empty because it just died.
But look,
so let's see if Z-2 is kept in the third cycle.
It depends on what is below it. Yeah, but depends what is below it.
Okay, but it's not creating Z plus 3, basically. Minus 3, sorry.
No, because probably there is not enough mass to create.
So you only expand if you have live enabled points, whatever they are.
Is it symmetric?
Z-2 had one active node, And this other one has multiple active nodes. Okay.
Because they come from the level below, that probably is
yeah.
three.
Oh, okay, because so it doesn't generate a new one.
Just a consideration: is it symmetric?
Doesn't seem to be.
Symmetric on top of Z, I mean. Z1 and Z-1, Z2 and Z-2, are they symmetric?
In this case, it looks so,
This
right?
one looks like it, yeah.
There can be a case where this is not true. But well, we can compute everything and don't care.
Yeah. These are symmetric. -2 and 2 are also the same. And that makes sense because we started from one slice, so it's going to grow
so
the
slice
same.
is getting, So in theory, we can just compute going up and printing mirrored.
Yeah. Depending on what outputs it wants, we can literally just calculate one way and then...
Oh, yeah, it's true that we just have to calculate stuff.
Then mirror it and that's it.
We don't have to print them, sorry.
Yeah. Oh, we need
After
to
6
calculate...
cycle... Yeah. What?
We need to count how many active there are, right?
Yeah,
Yep,
after
certainly.
6 cycles. Okay.
Yep.
How is our input? Can we take a look at our input?
Of course. Command B, you said? Yes.
Okay,
It's
our
much
input
bigger.
is 8 by 8.
Mm-hmm.
Okay. Just a question about the example that is there.
Yeah.
Can you go back to the README?
Of course, going to it now.
Go to the first step.
Oh, it does expand also in other dimensions.
I don't think you can do this with a matrix. You have to do this with a Nash map of the coordinates that point to a Boolean that is active or dead. And then you do a sparse 3D matrix, basically.
Mm-hmm.
And then you compute the new matrix at every step. If you scroll a little bit up again, my question is, in the cycle, in the first cycle, scroll down.
Okay.
Okay.
So this is the...
After the first cycle, Z0, the central hash, why is alive? It say that they come alive when they have exactly 3 neighbors, but this one has 4 neighbors.
Wait, the hash is alive or is active or not?
Hash is active.
Are we sure?
Yes. It was written somewhere here.
Yeah, I remember it. Probably a little bit up.
Active is hash, inactive is not.
Okay. Makes sense.
Back to us. The central one from dead become alive, but it has 5 neighbors, or I'm wrong?
Let's read the rules again. If a cube is active...
No, if it is inactive.
No, if it's inactive, but exactly 3 of its neighbors.
Oh, they need to be exactly 3.
Yeah, but those are 5.
Yeah, but this one.
Oh, but exactly 3, not at least 3.
No,
it is exactly 3. They don't consider diagonals.
We say that we are considering diagonals because we have 26.
I think we are.
I know what is happening. I know what is happening. The central one in Z0, the central one there, is not the same central one down there. And now I will explain you why.
Please do.
Okay.
Because you lost me completely.
The start schema. Okay, let's do it together. Go on the. Let's just compute the evolution of the central layer.
Okay. Do you want to start with it in a new file or something?
Yeah.
Right.
Go here. Cool.
Okay.
Perfect. So, the first dot in the top left.
Actually, I'm just gonna put them on the same. Yeah.
Stay dead. That active shell dies because there are no 2 or 3 neighbors, right?
Let's check the rule. 2 or 3 of its neighbors need to be active. No, wait. If a cube was that active? It was active. Yeah. So it stays active if it has 2 or 3 active neighbors, which it doesn't. So this becomes a dot.
This die. And the one after that has 2 neighbors, so it's not coming to life.
Exactly.
Okay, line after this.
This one stays.
This one
dead.
has 3 neighbors, so it becomes alive.
If we
Don't they have-
consider diagonals, yes.
The central one stay dead. Let's try it like this.
Okay.
This one becomes alive.
The center, yes. 'cause it's
No,
all-
sorry.
No,
the
it's
center,
got too
No,
many.
the center is
the central
overcrowded.
one stay dead, and the next one
Has 3 neighbors exactly.
1, 2, 3, so it stay alive. Okay. The line below, how it is behaving. This one has just 1 neighbor, so it dies.
Dies.
This one has 3
Has 3,
neighbors,
so it stays
so it
alive.
stay
It
alive.
has. Yeah, 3. You're right.
Stay alive.
The other
The
one.
next one has
Has
2
2.
and stay alive. But you have to compute the next line. Why? Because it can expand going down.
Mm,
No. Leave everything like it is. Leave everything like it is. Go
Okay.
create a line 5.
okay. 6.
Space-
Just we have space.
Space in line 5.
Okay.
Not line 5.
Hang on. This 2. I don't know how to set this thing up. Apologies. Okay.
There. That cell is below a cell with just 2 neighbors. So dead.
hmm
This one become alive because it has 3 neighbors from above, right?
Yeah, but only 2 of them are active.
No, they are 3 active. You have to look at the initial state, not on the final
Ah,
state.
you're right. You're right. You're right.
So this
Okay.
become alive, and the next one is dead.
Yeah.
Now, compare this with the first evolution of state 0 of the example in the README.
It has probably.
It has
nothing
an
to do with
dead
it.
line on the top, and
Sorry, I'm just moving these out so I can copy them over.
I think you can do with Control Alt and the mouse. You can do rectangle selection, but well,
I don't know, man.
okay.
Okay.
We have this as next. We have
So-
computed this next state. Go there in Z0 on the first next step and paste it after it so we can compare it.
It's different.
No.
Oops, sorry. Now it's.
No. Put a space
But
also
this is-
before Z1. Line within line 58 and 59, put a space so we can see better.
58 and 59.
No, you removed it.
So these guys move them out, right?
Paste.
Okay.
Okay. Do you see what is happening there? The output is the same. Because if a line is completely dead, you don't print it.
Mm-hmm. Would have been useful if they gave us this information.
Yes, but I think the trick is that you have to figure out this information.
Mhm.
You see? They say
Yeah.
level 0 is this one, but they don't tell you X and Y of the level 0. Fine, level 0 is effectively that one, but is one cell below.
Yeah. So the center moved basically.
Yeah, the center moved. It's for that reason that I was not able to map the center with the rules.
Mm-hmm.
And diagonals count again.
Yeah.
So every time we have a bunch of coordinates and we have to check also the layer around it. So if we have coordinates between -3, -3, and 3, 3,
Mm-hmm.
we have to check also between -4, -4, and 4, 4, because there can be an outlier that can change, become live or dead.
Yeah. Okay.
So how are we going to represent this? Because the idea of the sparse matrix is nice, but then does it mean that in practice we need to shift things around if there are empty
No, in the
lines?
sparse matrix you don't have to shift stuff. We have to keep track. Of our sides. I mean, our diagonal. We don't care about exactly what is the position because we just have to answer with the number of cells. We don't have to print them. So what we can do is having a hash map with a tuple with 3 coordinates and boolean, and a boolean that tell you dead or alive. So that is a boolean.
So let's start.
Yeah.
So that grid is going to be a hash map, you said, right?
Between
you'll
a
need
tuple
to-
of U64, 32.
Yeah.
No, E, because
No.
they're also negative.
Oh yeah, you're right.
They can expand in negative ways. They can go everywhere.
Yeah, you're right. I32,
Three of
I32,
them.
I32.
And a boolean after the tuple. No, out of the tuple.
Yeah.
They map to a bool.
Or do I lowercase bool?
Yeah. Okay.
Okay.
Can you? No, you cannot do an. Oh yeah, I see what you mean.
You can't do this.
No, you can. Sorry, I
This
didn't
is-
realize. Yeah, okay, now
It
makes
should
sense.
be hashable. Oh, sorry. Hash map.
You need to import, the hash map
I hope
from.
we don't get to see Slack.
We
I
don't
need
see
to import it. It's not complaining about it though. Sorry.
New hash map new. No.
Yeah, that's
Yeah, you
what I
can do
wanted to
hash
do.
map column new
Yeah.
and
And
parentheses and and that's it. But you probably need to import it.
now I'm waiting for it to complain.
Okay, now it's complaining.
Import STT collections hash map. Yeah, that's what we wanted.
Perfect. Save again.
Yeah.
Okay.
Now it's complaining we're not using this. And this is not even grid. This is pocket.
Cube.
That's what they call it.
Yeah, it's the pocket. Yeah. The cube.
Or let's call it cube.
Make it also mutable.
Yes.
We have to add and remove stuff. Yes. What is handy, but we can do that at every cycle. But what would be handy is to keep our size. So our coordinate of our bottom left and top right. But
in space, so it will be 2 points.
It will be basically
2
points, 2 3D points, one made with all the mean of all the coordinates and one made with all the max of all the coordinates.
So basically a tuple like this.
A tuple of 2 tuples, a tuple of oh my god.
Oh wait, because we need
the corners that we need are 2.
Do you want to make
of 3 elements? So,
do you want to make a struct for this maybe?
Sorry, I need to ban a spam bot.
Fun.
Yeah.
Want to become famous? Wonderful. No.
by followers, I read flowers. Flowers. Well,
why not? Sure, nothing better than flowers on the internet. Okay, so
saying, let's make a type out of that.
Yeah, we can do even a type alias, by the way.
I'm not familiar with type aliases.
How?
I think you just need to say type and then either C2. Sorry, type and we give it a name. Let's call it point.
Point.
Okay.
And then equal that. And then semicolon. Okay. And I think now you can just use point everywhere where you have these 3 things.
Okay.
So again, we need to keep 2 points that are top left and lower right. I don't know how to call it them.
The corners of our space, basically.
Yeah.
Yeah, top left and bottom right. Yeah. Do you want to keep them separate or do you want to keep them as a tuple?
Well, you can keep them separate in a tuple. I have no strong feelings around.
Let's
just to be explicit.
Yeah, it's
not really top left. It's like
high top left and lower bottom right.
Yeah.
Basically, they are the opposite of the other. Call them like you want.
Yeah.
A and B. A and B.
No.
P1 and P2.
Corner, whatever, high corner and low corner.
Make them mutable and semicolon and
and we'll need to assign them a value, right?
But when we pass the input, we assign when we pass the input.
All right.
Can I do this?
Now we have to pass the input.
Yay. Let's take a look.
I don't know if Rust is gonna be happy with that, but let's see.
Unused variable.
Yeah, give us a moment.
For now, it's happy.
Cool.
Okay, so we need to parse the lines, basically, right?
We have to take the lines. We know that Z for this iteration is 0. So Z is 0 in for the input.
Yeah, this
we
is
have
just
to
the
parse
unit.
the line, keeping track of Y. Let's say that Y is the number of the line, and X will be the number of the chart. So input lines enumerate or iter enumerate. Do we have? Oh, no, we have enumerate here. Okay.
Enumerate.
So this
is going to be a for each, basically. Or we can.
For each takes for each.
Because we need to split them, right? We need to get each character in them, and for each of these, push them
for
in the
each
cube.
give us the lines that they will have Y and the line, right? Here we declare a closure.
Sorry.
Yeah.
Yeah.
Y, Y.
Yeah.
Comma. Okay. Because we use the enumerate.
Ah, okay.
Yeah. Inside.
And now you can do the chars of every line is the coordinate X, basically.
Yeah. So
dot enumerate dot for each again. Enumerate because we need is X. Dot for each.
Which is underscore. Sorry.
At this point, you have X, comma the state. The cell.
Cell. Let's just call it cell. Yeah.
And here cube dot insert.
Insert. You're right.
And we have to create a point. Curly brackets.
Curly.
Jesus,
this is hard to read, by the way.
It will
X,
be X, Y as 0 because
0,
Z is always 0 to
and
start.
the value is going to be
true if the cell is a sharp, or false if the cell is a dot. So cell equal a sharp.
I don't know if it knows how to do this.
Yeah, I think you can do that because it's going to be a sharp.
No, it's just that one, not ternary.
Yeah, you're right, because
it's a
boolean.
Put a semicolon at the end of all these, and
now I think you need parentheses and not curly brackets there because it's a tuple and not struct.
Okay, so
is it
expected function tuple structure tuple variant?
I think he wants curly. Try with curly.
Okay.
Was complaining with curly.
Yeah, I think so. Yeah. Expected struct variant or union type. Found tuple not a struct. So yeah, because it's not a struct. It's a type alias, which is what Luciano said.
Try to just put a type without saying point.
Oh, just the tuple.
Yeah.
Yeah, that might work.
Is it happy?
Yeah, and it's saying point is used. It's not happy with the for each.
Can I suggest we use a regular for loop rather than for each?
Yeah, I fully agree.
I was not able to read what was complaining about, but yeah, okay. What was complaining? Sorry, guys, I lost.
Just a second. I'll give you the complaint just in a second now.
So that will be for line, Y comma line, right? You need to destructure there. Yeah. I think you might need the parentheses.
I don't. Jesus, sorry.
Yeah, okay. And now inside we do the other for.
Yep. How many parentheses do I need? Just these, I think.
Okay, now I will suggest we still do another regular for. We do for.
The for each is still giving 2 parameters.
So for, this is going to be X and cell, or just value in this thing. Is it happy? It is happy.
Perfect, and then we do. I think it's more readable this way.
I agree.
And now you need a semicolon there in line 12.
Yep. X.
No, why is complaining? Cannot
It's
complain.
U
Oh,
size.
because it's U size. Okay, so you can do as I32. That should be easy.
Nice.
Okay. In the meantime, we can also compute the 2 corners while we go through. Because basically we have to keep track of the size of the number of lines and the number of the max number of chars. Okay, the number of chars is always the same. So X and Y, Luciano, at the end of those 2 fours are discarded. We can't keep them. We have to declare outside of it a variable to keep track of them.
We can create new variables and just copy the value, right?
We can literally store them as high corner, right? And then we can
low corner is low corner. We know that is 0, 0, 0. You can initialize it, because we start from 0, 0, 0. Yeah, our top.
Okay, because we're in you're right. Because we're looping over.
In line 7, you can already initialize low to 0, 0, 0.
Yep.
I think you need an equal, not a. And you keep point. You do equal.
Frick, you're right. And it should be. Apologies. Yeah. Okay. Now it's happening.
Okay. And I counter. Yes, you can initialize it also, and then inside the loop we go if is bigger, replace.
Yeah.
In line 6, you can initialize it to 0. No, in line 6, I corner. You initialize it to
like
0,
this one.
Yeah.
Okay.
And then we just we keep increasing it.
And there we say, okay, the tuple that is k, we can assign it to something. That k.
We can. We'll store this as
a variable.
So let new point with an over p. Sorry. New point.
I think you can do greater with tuples in Rust. So if new point is greater than I corner is equal to new point.
Let's see. High corner. High corner. Crap.
No.
Crap. What I do?
No.
Let me copy.
Copy and paste. Strike it again. And he's complaining about the comparison.
Unnecessary parentheses because they're not needed.
Complaining about parentheses.
Low corner. Unused variable. Okay, cool. It will be used. Okay. Beautiful. This worked remarkably well.
It's great that we have built-in comparison of points because it's tuples of integers.
Tuples. Yeah. So at this point, we have to do 6 loops, right? That the README was saying after 6 iterations.
Yeah.
So we can do 4 underline in 0.6.
Yep.
Yes.
Should work. Yeah. So now we need to calculate this.
Here we can basically we have a state. We need a function that creates the new state. So cube is equal to next state of cube. Let's to call it. I don't know if you can. Let's see if we can do this in Rust because I started to see.
We need to make a function.
And you. Yeah, you need to do a function and say that function returns a new cube, basically.
A new point.
Type.
Do you want to define a type for the cube? No, we can't.
Well, we can define a type alias. Why not?
Yeah, you can. Let's do that.
Okay. So cube, which is going to be hash map of point of boolean.
That guy.
Exactly. Semicolon.
With.
That's it.
Like this. Okay, cool. That's fine. And let's
cube
also
take a cube.
And returns a new cube.
And I corner and low corner if we want to. Fuck.
We need to recalculate that.
We need to, if we give them those 2 numbers, it has to give us back those two points.
Unless you pass mutable references to these numbers.
Yeah.
And then it can mutate them. Or we return a tuple of a cube and 2 points. and then we reassign them manually.
Okay,
Why
a
did-
cube at 2 points. Okay.
Why did we need these?
To know the 4, it has to start from somewhere. So
You know what can be an alternative?
Mm.
That we create a structure that we call state.
Mhm.
yes.
And a structure state contains high corner, low corner, and a cube. And then we can create a function called next state that we just takes. And we can even build that as a structure function. So it just takes self and returns a new state.
Okay.
You're
let's
right.
try
Okay, state, which is basically a cube.
and the 2 point.
Yeah, so high corner, which is going to be a point.
Probably you have to
low-
declare the point before the struct, or is smart.
Oh, yeah, you're right. Let me
I don't know
just-
if he's smart enough.
Okay, point, and
A cube called of type cube, and at that point you have to move the cube.
will do.
Okay.
Yeah, okay.
And
then this is gonna be an input.
Take a state and give a state.
Right? The function next state. I can just copy this, right?
Yeah.
But it's not going to be.
Yes, and the
cube,
difference
it's
is
gonna
that you
be
can take
self.
a reference to self or just self. Yeah.
Ampersand self.
Actually, you know what? Yeah, it's important to mention the difference. So if you do only self, basically when you call that function, the structure itself is going to be moved. So it means that you cannot use that structure anymore, which I think could be an interesting property to have here. If you use a reference, you are essentially referencing yourself and not moving yourself out.
Yeah.
So you can reuse the same state over and over and call next multiple times.
Essentially, it's the difference between if we had self without ampersand, we would have to do this. If we have it with ampersand, we just need to call this on it, basically.
Yeah, the difference is that when you do that without ampersand,
Mhm.
you are not allowed to use cube anymore after line 33.
Yeah,
You can use the return state, of course.
exactly. So you can go cube equals the result of this.
Exactly,
basically.
exactly. Yeah, that will work.
Yeah,
So, but
state,
for now-
not cube, because we have to create a new variable called state.
Yeah, we'll call it state, which is a state.
Oh, no,
which
we still
is...
need cube.
do we?
Don't do that. Go back. Control Z.
I did, it's fine, man, don't worry.
Because we create state in line 31. We have to do the parsing somehow.
Yeah, you're right. That still needs... Well, this is the initial cube, basically.
Yeah, initial cube. Okay. If you want to.
So, because that's what it is. And then we have to define...
A new state, exactly.
State is state...
Mutable, I don't know, mutable.
Doesn't
Yeah,
have to
it
be
will be
mutable.
mutable. New...
Does it?
I'm asking you.
I don't think. Well, let's see. Let's keep it this way, and then we'll try.
Technically,
we don't need
we're
the new
not.
if we just pass variables. Right?
Exactly, because we can reassign it all the time. But it's going to be a new state. We're not mutating the old state. We are just dropping it.
Yeah.
So, wait. So, currently we're using a reference to self here, which means that this thing is going to stay as it is. We're just going to call a function on it, and it's going to change itself, which means
probably it's better the other way around.
What I'm suggesting is that we remove the ampersand and we return a new state.
Okay.
And the reason why we need to do that is because we need to look at the entire space, at the entire grid, to be able to count all the neighbors without mutating it. Yeah, otherwise, if we mutate it on the go, it's not going to be
it's not going to
valid anymore.
And you're there, right. you don't do new there.
No,
because we didn't implement new. You just do state, curly braces.
Oh, yeah, you're right.
You can also implement new if you want, but I mean, this is the shortcut.
You have to put in high corner, low corner, and init cube. S cube.
So cube, column, init cube.
The other two have the same name. This one has a different name, so you have to.
It's called.
Cube.
Yeah, fair
Cube
enough.
colon or
Yeah.
yeah.
Okay,
And the
let me put
semicolon,
the semicolon.
and also semicolon in line 35.
It's not complaining about it though. Okay.
Is your Rust analyzer fine? By the way, we are returning nothing. Obviously, it's not happy.
Yeah, it's unhappy there. Cool.
So at this point here, we have to do our free nested for.
Yeah.
Or we can do a function that is like count neighbors.
But we have to, basically what I was thinking was, we have to do for Z, Y, and X in range from lower corner to high corner. So for all the cell in our cube.
Okay.
Count the neighbors. Yes, we need a function to count the neighbors because there are 26 neighbors.
Yeah. So
count the neighbors, and if the neighbors are rules, we do stuff in the new state. So we also need a new cube that is always an hash map of type cube. That is the one that we use to create the return state, because here we are creating a return state.
Yeah, we need to create a new cube, but the new cube we can create it at function level, I guess.
Yeah, there. No?
Yeah, we need to create a new high corner, a new low corner, and a new cube, and as we go, we'll populate all of them and return a new state.
Yep.
Exactly, pretty much like that.
And the return statement is a state, curly brackets, and the free. Call it cube and not init cube.
Yeah, you're correct. Well, I can call it new cube, but yeah.
By the way, later on, remind me that this is a good use case for the default trait.
Okay.
Curly,
correct. Not. Sorry, my man.
For that, you have to remember me how it works, the default trait, because I don't remember.
But basically, the idea is that we could avoid that duplication between line 22 and 25 and 13 and 15 by just saying create a new default state. And that default state will contain all this stuff.
Fair
but
enough.
This is something that I would recommend we do later because it's just ergonomics and doesn't matter right now.
Fair. Okay, so we've got this stuff.
I was thinking, guys, if we need the lower corner and the high corner, I'm a little bit puzzled here. Okay, let's see. We have an hash map of points that are alive, right? Or dead, but we just care about the alive one. The dead one are. If we point to a point that is not in the hash map, it means that is dead.
Yes. Right?
Yeah.
If we ask for a point in the cube that is not a key of the cube, it means that the cell is dead.
Well, if it's not a key, it doesn't necessarily mean it's dead, because it might just not be there.
It means that if you want, we can just keep the alive cell in the cube hash set, but I don't think it's changing a lot from performance point of view.
No.
At the point is not even an hash map, but is an hash set of coordinates of the alive cell. You can also see that in that way. What do you prefer? What do you think is easier to understand?
But then you will need to take care also of removing stuff.
Remove the dead one from the hash set if they die.
I think I prefer to keep them like this for now, at least.
Okay.
It's a very simple to understand and explain representation with a true false, as in the Boolean for a point.
Okay, now what I was thinking is the following. If we have a bunch of cells, for example, think that you have a cell at 0, 0, 0 and a cell at 10, 10, 10. Okay, they are 1,000 cells.
Yeah.
Right? Do we have to compute all of them?
Yeah.
No. because we only have to compute the neighbors of the cell that is alive here and the cell that is alive here. Because if a cell is in the middle, far away from any other cell, that cell is not going to die or born. I mean, it's not going to born, right?
So
Are
if we
you
look
sure
at...
about that? I'm not sure I'm following this.
Let's reread. I do get somewhat what Alberto's trying
You
to
have
say.
an initial, let's say that you have an initial schema of just two cells alive,
Mhm.
one in 00 and one in 1010.
Mhm.
And they are the
Yeah.
only two ones that are alive.
Mhm.
Okay.
The next iteration, they are all dead.
Yeah.
Okay.
But
Yes.
do you need to ask yourself, is 55 going to be alive? No, 55 is impossible to be alive. The only cell that could become alive are the neighbor of 00 and the neighbor of 1010.
Yeah.
Yes, but
Basically-
the problem is that you are not starting only with the corners. You also have stuff in between. How do you know? Like
If you
what?
have an empty zone, let's say that you start with a circle
Mhm.
of cells. The cell in this circle is of radius 10.
Mhm.
The cell in the center of your circle makes sense to evaluate it,
Well, you still need to kill it.
but it's not
Right.
alive. I say that it start killed. The only cell that you have alive is a circle of cell, like say that you have 16 cells in circle,
Mhm.
but the cell in the middle obviously is far from any other cell because it's
Oh,
far
I see.
away.
So you just look at the neighbors of the ones in the
Okay,
surrounding
so
area.
the idea was we take a list of all the neighbors of the cell that are currently alive.
Mhm.
Those are the only cell that could become alive. And then we always obviously compute the death rule for all the cells that are alive, and they have to. But we know what cells are alive because we
Yeah,
do
yeah.
the hash.
Yeah,
The hash
Roberto's saying basically that only the alive cells and their direct neighbors are relevant.
Yeah, so we can remove the two corners in this way.
We can indeed.
But is that an optimization?
It is, yeah.
It is
Or it
slightly.
simplifies as well?
I think also it simplify. On that, I'm not sure. It speed up for sure because, like I said, if you have 3 cell here and 1 cell here in 1010 or in 100 100, you think 100 100 100
Mhm.
100, it means that you have if you go with a 4 on 3 dimensions, you are doing 100 to the power of 3, that is 10 millions. You are checking 10 million cell that you know that they will never become alive because you have 3 cells in 00
Right.
and 1 cell in 100 100 100, and there is nothing in the middle.
Yeah,
Mhm.
correct.
So
Yeah, if you get there, you will get there through different iterations, growing and growing.
yeah, exactly.
So, yeah, fair enough.
Yeah. So do you want to do that?
Like I don't know.
Well, it would make sense. It's
Let's
less
try. I mean,
calculations.
let's remove high corner and low corner for now. Or let's comment it out, maybe.
Yeah, sorry for the stupid initial idea.
No, I
No,
think it makes a lot of sense.
it's very good. Now I need to remove it from everywhere, unfortunately.
The now state is
There's-
just a cube. Ah!
Yeah, this
Not
is a
just
bit...
that, but at this point, it makes sense to use an hash set, right?
Do you know what? Let's
Yeah.
just delete this, not comment this.
Yeah, sorry guys. Why you listen to me?
The only thing that I am
Why do you
curious.
listen to me?
Yeah.
Wait a second. The only thing that I'm curious about is now how do we know when we need to expand in the Z axis?
Because if you start with cell that are 001, all your neighbors are -1 and 1. We need a function that, given an hash set, give us back another hash set of all the neighbors plus the alive cell. So I give you a set A. You have to give me back the set A plus all the neighbors.
Okay.
So we keep
Then those neighbors can be dead or alive based on rules. And you can become dead or alive based on rules.
Okay.
Fair enough. I'm following now. Okay, cool.
Okay, so I'll get rid of state because we don't really need it.
But we still need the function next state because
Yeah, but that doesn't need to be as part of a struct which contains just.
no, it's just
Fair
a cube.
enough.
It's just a cube to a cube.
Yeah, let's simplify at this point. If the state is much simpler.
Okay, this is going to return a cube.
And it takes a cube, right?
And it takes a cube.
Okay.
And it returns a cube lowercase for now, if you want to make it work.
Hang on. Init cube. Ah, no, wait, it's not init cube anymore. This is just cube now. Cube.
El cube è un pilota.
There we go. Cool.
Okay, now do we want to use an hash set rather than an hash map?
Yes.
Yeah. Which I'll probably need to import.
Just change hash map for hash set, yeah.
Yep.
And now you need to remove Boolean from the declaration. You just need hash set of point.
Oh yeah, you're right.
And now there we need to do if cell
is
equal
insert.
Yeah.
Insert or add? How it is for
Insert.
Let's see.
You don't need the curly brackets.
I don't need the round brackets.
Yeah,
Right.
sorry, I want to say that. Probably you need the curly, but not the round.
Yeah. Cube insert, it's happy with this.
Okay.
Okay. Beautiful. Made some progress and the thing is cleaner.
So now the return cube, you can initialize it like in line 13.
Actually, I'm just going to call this old cube and call the new one cube.
Yeah, fair enough.
It is a new hash. It is a hash set new.
Can okay.
I don't know if you can do cube new.
No, because we haven't implemented anything for it.
I think you can do it because because it's literally an alias. I don't think it's creating a new type.
You're right. It does work. Wonderful.
Cool. So also line 13, but well, let's not bother about it now.
You're right. Let's just do it. Come on. Consistency.
At this point, you can probably remove even the type declaration in line 13. Line 13, you said it's a cube type.
Yeah, you're right.
The point is implicit, yeah.
Correct, you're right. It doesn't need to be done there. Okay, so old cube. Basically, we need to go through each, right?
We have to go through each them and the neighbors. So can we create a function that give you neighbors of a point?
Sure.
By the way, we have a question here. Sorry if I didn't see this one earlier. I hope this is clear now, but I'm going to try to answer anyway. So the reason is that we need to compute a new state based on the previous state. We could have made the state mutable in general, but in this specific problem, we cannot mutate the state until we're finished because we are essentially counting neighbors in a space, in a 3D space. And if we keep mutating all the neighbors while we change all the others, the picture changes as we try to do the new state. So we need to keep like a snapshot of the current state, calculate all the entire new state, and then that new state becomes the current state. So I think this is the reason why we are not using references. Do you all agree, guys?
Yes.
I do.
Okay, neighbor points, take a point and give you back 26 points.
A vector of point, yes.
You can actually do an array because we know the size.
It's always 26. Then
you're right.
So basically, you can just put the square brackets.
Okay. I'm not familiar with this.
point and then semicolon inside the point semicolon 26, I think. Is
Semicolon.
semicolon, I
copy.
think. Semicolon.
Ah, shit, I typed. Sorry, my bad. Mismatched types. Oh, okay, because I'm not
Because
returning it.
we are not returning it yet.
Okay.
So we have to declare an array of 26 points.
Also, you need to say that point is a type point. Line
Correct.
6.
Okay, so how do you define an array?
Is a good question.
And then we have to mutate it. We can define an array of all point to 0 and then mutate them.
I don't want to type 0 26 times if you don't mind.
Exactly. No, I think if you open a round bracket, 0, 0, 0, close bracket, call
Round
semicolon
brackets.
26. No, open the square one.
Okay.
Then open the round one.
Okay.
0, 0, 0, semicolon after the round and 26. Is it working?
Yeah, nice. By the way, quick thing here.
Yeah.
Remove points. Just a second, just to show something. We have a good suggestion here.
This, the mutation?
No. Line 9.
Okay.
So you can replace that with to do. Go last line to do.
To do.
And that one. Yeah. So this is and save. This is just a trick in general while you are working, if you don't want to be annoyed by that error because you are still figuring out what to return. This is just a trick we can use rather than just making up something we want to return just to match the type.
All right, so fair enough.
That can be useful. Thank you for the suggestion. But well, in this case, we already made what we want to return, so you can also go back to points. But I just wanted to show the good suggestion.
That was very good indeed. Okay, so
now we have, if you don't want to write 26 times the same stuff, we have to do free loop, one inside the other, z, x, and y, from -1 to 1 included.
Yeah.
So for z equal, so for z in equal 1, because we have to take also.
Sorry, it's not -1.
-1 equal 1. From -1 dot equal 1.
Because you want to include 1. Yeah, you're right.
Cool.
Yeah,
then y and then x. The order is not important, to be honest, but
we're doing them as specified. Sorry, there's a fly. There's some sort of flying thing. Jesus, my typing is crap. Apologies, guys.
Okay. Here, if all the coordinates are 0, we have to continue.
0, 0, 0.
Yeah, we just don't do anything in this loop. Else, we have to assign to our points the current tuple. Well, the continue was not needing the else because it was.
Actually, I can just go if this does not equal, then we can do our work, right?
Yeah, same.
Just saying. Okay,
square,
push.
No, I think you can use the square bracket here for array.
Okay.
X, Y, and Z is a point.
And no, because the array is flat.
You can
yeah, sorry, you're right.
So we need to linearize that. By the way, let me stop you there for a second because we have a suggestion that I'm gonna convert into a question, which is the points are already initialized. You don't need the for loop. And I suppose the question is, can we just loop over the points?
Yeah, but we don't know the coordinates they map to.
We don't have a way to map the coordinates, right? That's what I was thinking.
Eugene, line 8.
Yes.
Let mut index equal 0.
Yeah, and then we just increase it in the inner loop.
Why 9?
Because they mistyped, because they were close to each other.
Points of index in line 13. Line 13. Go to line 13.
Yes.
Points of index. No, line 13. No, 14.
Jesus.
Now 13. If you change the line number, we are not going anywhere.
Yeah, okay.
Equal.
Yeah, you
open
can
round
just...
brackets.
Yeah.
X, Y, and Z. That is not X and Y, Z. Exactly is X plus point dot zero.
You're
Plus
right.
point dot zero. Dot zero together. Okay. Epsilon,
Yes.
Y, sorry, plus point dot one, and Z plus point dot two.
Correct.
Why, Eugene?
Point.
One.
Not one.
One.
Jesus. I'm sorry.
And we have to increment the index. So index plus equal one. No, inside the if, not outside of the if. Inside
out.
In.
Oh yeah, because we don't care for the ones. You're
we
right.
have otherwise we have an out of index because we are looping 27 times.
You're correct, because we're going through the point itself as well.
We can write a small test to test if this works.
Yeah.
So.
By the way, there is another interesting comment before we write the test.
Okay.
That says that there might be a performance issue in the Rust compiler when you do many nested loops and use that range equal. So this is something we could actually test at the end.
Yeah.
So it's an interesting one because we have all the benchmarks in our repository. So I would be curious to leave it as it is, complete all the exercise, do a commit, and then do a PR where we remove the equal and just increase by one the boundary, and then see if there is really a benefit in performance. So this is a great suggestion, but we have all the tools to test this, which is cool.
It's going to be really cool. Yeah, let's do that.
Let's do
the test. Let's write it like this for now.
The test neighbor.
So, neighbors. I'm sorry.
Points. Neighbors. Well, okay, let's test something.
Test neighbors, it don't matter. Neighbors.
And then
points.
we ask the neighbors of 0, 0, 0. And we must have 26 numbers. And
okay, so let's result. Is this
now here dbg exclamation mark result? So we dump it and we see if it makes sense visually. Then we write the assert, or we copy and paste the results. Otherwise, you have to write forever. Try to run the test.
Let's see.
Obviously, if we don't have any syntax error around,
shouldn't be, but let's see if we're lucky.
Did you run all the tests or just
no, just
no,
one?
I just clicked on this one.
I think he has to compile in any case.
Yeah, it's probably installing everything.
This is brand new on my machine, so
no cache.
Yeah, it's strange. To be fair, I didn't run most things in VS Code. I run them in the console, like in an actual terminal. So I think I'm not sure this is using the same shell.
No, maybe it's using your terminal.
Okay.
I think.
Yeah, I think the cache will be in the target folder. So if you don't delete that, will survive across terminals.
I have not.
But maybe it's the first time you're running this in this machine.
Okay, copy that.
Oh fuck, man! This is.
If you prefer, you can write it by hand.
No.
Square bracket at the beginning.
I can put it in later. Ah.
Yeah.
Jeez.
Okay. We can assert the neighbor point, give that, but let's look if it makes sense. -1, -1.
Yep.
Then
0,
-1, -1, 1, -1, -1. Then we go back to -1, 0, -1. Then we go to okay. Then we have
1, 0, -1. -1, 1, -1. 0, 1, -1.
Yeah, fine.
It's correct.
Okay, do convert in assert EQ.
Okay, result and
Result
this.
colon, comma, che colon. And close
Let
round
me-
brackets somewhere.
At the end of the rainbow. How does this editor go to the...
Semicolon? No.
Doesn't matter. How... never mind, I'll just scroll.
You want to reformat it?
No, I wanted to just go to the matching
Okay,
brackets.
now it didn't. Now the compile was fast.
Fast. Wonderful. So this works. Can I delete this thing?
No, keep it. Why not? It's a test.
I wanna format this thing.
Format it, but keep it. It's a test.
Yeah, in fact, it's fine. You're right. It's a test and it's a useful one even. By the way, are the others... Is the syntax different in the others? No, they've all got the same spacing. This is 4 spaces, and I wasn't sure if the others were 4 or 2. Just looking at this randomly. Okay, cool. Do we...
I care about spaces only in Python.
Yeah, fair enough. This is a default VS Code thing, and I didn't know if it's
Okay,
the same for
so
us.
now
Next state. So we've got the old cube into iterator. For each.
We have a beautiful suggestion.
Do we?
please, what is please?
Please.
But I'll triple in the
please,
same. Yeah, that's exactly what I wanted to do as well. I am
it's
of
not
the same mind as
you. Control Shift P format is not working.
I don't know. Format document?
Format document.
Try.
He did something.
Oh, yeah, nice.
Nice.
Done.
Lovely. There
Magic.
you go. Your wish and my wish have come true.
Okay, back to
All right.
us.
So we go through every...
one because it's 1 hour and a half that we are streaming.
Actually, yeah, we should probably...
What to do next? You can put the comments of stuff
Mhm.
to do.
That's a good point. Okay, so
We have two.
to do for each point
Get a list,
in the cube, get the neighbors.
For each point in the cube, get all the neighbors. Yes, for and put them somewhere.
Yep.
For all the neighbors and store them somewhere.
Yep. For each neighbor,
stored variable and the existing cell, we have to apply the rules.
For each neighbor and the current point,
we have to apply the rules.
Read me, because I'm not going to type them out here. Oh, sorry. Yeah.
And this is what we have to do. So, and the rules are count again the neighbors that are alive, that we have to create a function to get the alive neighbors, because with the function that we have, we just have the coordinates to check.
You're right.
Then we need another function that implement a function that check the number of alive neighbors.
Yep. Function to check alive neighbor count. And
because it's needed by the rules. Done. Then we retard the cube and we do this 6 times.
Exactly.
The logic is done.
And then at the very end...
At the very end, we have to return the
total number of alive
total cell
points.
that is cube.len at that point, right?
It should be, yeah, it should be indeed. Well, let's just check that that's what it wanted, because I don't remember.
Yeah, I think it was the number.
Starting okay. How many cubes are left in the active state? Yeah, you're correct. Number of alive, okay. Cube length.
Cube.len.
Yeah.
Yeah, cube.len.
Wonderful. Okay, so
but
I'm going
this
to commit
the
this.
next time at this point, because we ran out of time.
Yeah, it is quite late.
Yes. It's quite verbose as exercise. I mean, the game of life is always
tricky, yeah.
Even bidimensionally, you have to do a lot of code.
Year 2020, exercise 17, part 1, work in progress. Committed and pushed.
Cargo tests are working, so we are not breaking our build.
They should. run because I'm returning the same things. Test 1, tasks.
Okay.
Actually, I could just run tests. There we go. Let's see now. It should be fine though, because we just added a new test and it worked. Cool.
Yeah,
so that's all pushed. It's all fine. I'm gonna stop sharing my screen then.
Can we wrap up?
Who wants to do the closing? Roberto, you should probably do it.
Yeah. Okay. You can find the recording on YouTube in some time. The link is in the Twitch channel in the About section. If you're watching this on YouTube, we stream every Monday, 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description and give us a follow so you can be notified. Feel free to leave us comment, PRs, like you see in this episode. We are merging PRs after we check the performances, because I don't know why, just because we like to do that. The repository of the code is at this banner that is down here. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be shiny, beautiful solutions. We are trying to get it working. If you know better ways of doing stuff, comments, pull requests, so on. Thank you all for all the suggestions from the people that were in chat. Do we want to write somebody, Luciano?
Yes, I'm gonna start the raid in 3 seconds. So thank you, everyone. See you next time.
Thank you.
Next time.
See you.
In 5 seconds, we're gonna start the raid.
Almost there.
2, 1, bye.
Bye.
Bye.